The extraction technique shown in two parts, extraction and neutralization and isolation. It's also highly recommended that you carefully label all of your different beakers and flasks. You can use label tape, a wax pencil, or even a paper towel as shown here. More so than any of the other techniques, you will need to make sure you are prepared for the extraction procedure. The procedure can be shown in a variety of ways, written out like you've seen in your lab handout, or in a flowchart, also is shown here. Make sure you get your gloves and safety equipment on. To begin, you'll need a 15 ml centrifuge tube and approximately 150 milligrams of your mixture. The first step will involve dissolving the organic mixture in a suitable organic solvent. In this case, we're going to use diethyl ether. When working with diethyl ether, you'll note that parafilm is usually on the storage container. Remove this parafilm. It's there to prevent vapors from escaping the container. You'll need enough to dissolve. For the amount that we're dealing with, about 4 milliliters is good enough. Make sure you cap all your containers. You'll notice also that this person is stopping every so often to open the container and release the pressure. In the process of mixing, enough heat is generated to cause ether to evaporate, generating enough pressure that could potentially cause the container to pop. For this procedure, we're going to start with the sodium hydroxide extraction. The sodium hydroxide will react with any acidic components within the organic mixture, making them water soluble. Make sure you cap your container. To begin, we'll add about 2 milliliters of 3 molar sodium hydroxide. Give it a couple quick shakes. Remember to vent. Once the layers have been allowed to separate, you'll want to pipette off or remove the bottom layer from the centrifuge tube. The bottom layer happens to be the easiest layer to remove. Feel free to talk to your TA about why the bottom layer is easier to remove. In this case, we're using a glass pipette for more accuracy. Again, we'll wash with a fresh aliquot of the 3 molar sodium hydroxide. Cap, mix, vent, repeat. And again, remove that bottom layer and keep it with the previous layer. As we stated before, the sodium hydroxide extraction will react with any acidic components, making them water soluble. Now we'll continue on and do an extraction using 3 molar HCl. Obtain approximately 4 to 5 milliliters of the acid. The acid extraction will react with any basic components, making the basic components now water soluble. Just as we did with the base extraction, you'll add approximately 2 milliliters of the 3 molar HCl. Cap and mix. Vent, cap, mix. vent. You'll notice that this experimenter is leaving the cap loosely attached. This is because pressure can build up. We want that pressure to have some way to escape as opposed to breaking the container. We'll remove the bottom layer again. This should be the aqueous acid layer. And again, we'll wash with a fresh aliquot of the 3 molar HCl. Cap, shake, vent, cap, shake, vent. And remove the bottom layer, combining it with the acid extract. We'll now move on to the neutralization and isolation technique. We're now halfway done. We should have the organic component in the organic phase, we should have the base component in the HCl extract, and we should have the acid component in the sodium hydroxide extract. We'll start with the NaOH extract. Remember, this has the acid component in it. We'll add small amounts of 6 molar hydrochloric acid to the sodium hydroxide extract to neutralize the NaOH. We're going to continue to do this until we see a change in the pH or a precipitate form. It's hard to see in this case, but if you look very, very carefully, you may notice that the solution is becoming slightly cloudy. We can test the pH now. In this case, we're using blue pH paper. When the blue pH paper turns pink, the solution is acidic. We'll set this into an ice bath, carefully pack it so it doesn't spill, and move on to the hydrochloric acid extract. In this case, we want to neutralize the hydrochloric acid. We're going to use 6 molar sodium hydroxide. We will slowly add the sodium hydroxide to the HCl solution until we've changed the pH or until a precipitate form. Notice the cloudiness. Here we're using red pH paper. When the red pH paper turns blue, the solution is basic. Finally, we want to work with the organic solution. We want to remove any of the acid or base impurities that may have been left behind in our extractions. So we're going to wash our organic layer with water. In this case, we're going to use 2 mils of fresh deionized water. Same process as before. Add, cap, shake, vent. Once we've removed all of the visible water, we'll need to remove any small amounts of water that may still be left behind. What we're going to use is a drying agent. In this case, we're using sodium sulfate. Sodium sulfate is a salt and will absorb water. You will need to add enough sodium sulfate to dry your organic layer. Your goal is to see excess drying agent that appears the same in the organic liquid as it did inside the container from which you got the drying agent. You will let this sit for a few minutes to fully soak up all of the water. What we can now do is decant the liquid, which means carefully pour the liquid off. and set in the back of the hood to evaporate the solvent. We can now go back and deal with the acidic and basic components. You have insoluble solids in an aqueous environment. To separate a solid from a liquid, you'll perform a filtration. The filtration technique is explained in another video. Please feel free to check out that video for helpful hints on how to perform a filtration. Another common mistake when dealing with extraction, students will think that a layer is waste and they will throw it away before the end of the experiment. If you made a mistake and that was the layer that you should have kept, you now must start the whole process again. Do not throw anything into the waste until you have your final solid product. Once you have the solids, you will then be able to weigh them and obtain a melting point to verify the quality of your extraction. And now you're done. Feel free to clean up all substances.